Okay, so today we are looking at the first day of the graph of linear functions, and we're mostly just talking about slope. As you can see here, we have these three objectives, which is determining the slope and calculating rate of change. Rate of change is slope. And then we're also talking about just the graphs of linear functions and their key features. So today we're going to be definitely hitting x-intercept, y-intercept, 0, and slope. And we are going to be talking about this for the next couple of days. So it does seem like a lot just on these objectives, but it's mostly the introduction. And so, like I said, for today, the big part about it, at least for this first half, is determining the rate of change. Rate of change. So that's telling me how fast something is changing, obviously. Rate of change, or what is also called the slope of a linear function from a graph. Now here we have a couple different ways. This is what we're focusing on, which would be my rise over run. And I'll show you in a little bit what that really is. And I like to say really rise or fall over run, not just rise. Because sometimes you don't rise, sometimes you fall. This little triangle right here for both of them really just means the change in y, and that's why it tells you there, change in y, that little triangle symbol, change in whatever it's next to. Or this formula that we're not going to hit today. We're just going to hit that on the next day. But when I'm using my rise over run method, I gotta be making sure I read that like I read sentences, right? When I started using reading the sentence, I said when using the rise over. So I'm reading from left to right. From left to right. So wherever I pick a point, the next one has to be to the left of it, right? So if I start right here with this blue point, I've got to make sure that the next point, the next point that I'm hitting is anywhere on the left or to the right of it, because I'm going from left to right. So right here, the next point is going to be somewhere here, just in general. Okay. Select 2 points. That's step 1. Make sure they're nice. When we say nice, all that really means is a good, perfect point. Perfect. You've got whole numbers or numbers that are on a graph. Clearly defined. Now, I've got to start with the point on the left, right, left to right. Count up if your line's moving up. So if it was going that way, I would count up, or count down if I have negative slope until I'm at the same height as the second point. Then the number of units you counted up or down is the change in y, or this would be the rise / fall. So what I mean that right there, just in that first or the second step, here I'm going to start with point number 1. We already selected it. And I'm going to go down 1, 2. And here is point number 2. I just want to go down to where that point is. So if I'm going down, my rise is really -2. It's not a rise. That's why I like to call it fall if it's a negative slope. I've fallen down 2. And then here's the third point. I am going to count to the right until I arrive at the location of the second point. And the number of units we count, the number of squares, just kind of depends on what this is going to be the run or the change in x. Here, this graph doesn't label my units. Units is what you count by on the graph. So if it doesn't label them, I'm assuming this is starting with the ones, right? So this box kind of blocks it, but here I would have the origin somewhere here. And then I'm kind of remaking this graph. Let's see. There we go. And then somewhere here would be 1, 2. So then this is 3, 4, and 5. So I'm just assuming this is going by ones. That's why right here I'm saying my fall is 2 And now my run, we're going to count it out. Let's see what my run is. 1, 2, 3, 4, 5, 6. So run 6 to the right, 6. All right. Now my step 4 is just going to plug in my rise or fall number and my run number and simplify this. So get this to be as small as it possibly can. So here is my fall. We fell 2, run 6. And now if I want to get this to be its simplest form, still in a fraction, I can do that really simply with decimals. So here I'm going to type in what we just had, -2 over 6. That gives me that ugly decimal, but if I click on that little fraction button on the side, it gives me -1 over 3. So there's the simplest one. So now we're just going to try out a couple ones and see what we get. On these next ones, I don't have a point picked out, so that's step 1, just practicing step 1. Pick out my points. So I'm going to do step 1, and I want to pick a really nice point. So this point right here wouldn't work for me, right? It's not perfectly on there. I want to make sure I'm getting something that's perfectly on there. So this one right here, that's a good point. This one's a good point. All right, step 1, check. Now I'm going to do step 2, which is, let's see, point on the left, count up or down. Okay, I see this one's going down. So I'm going to go down 1, and then it looks like I'm right there. So -1. Okay, -1. Now I'm going to be looking at my step 3. Let's see, what's step 3? Count to the right until I arrive at the location of the second point. Okay, let's count to the right. 1, 2, 3. So I did +3 to the right. Step 3 is done. And very last thing. Just one more thing. I am going to plug the rise and run values into m equals rise over run and simplify. So let's do rise over run, step 4. Rise or fall, I like to say fall, over run. So here we fell by 1, which gave me -1. And then I went over to the right 3, +3. We can plug this into decimals to see if it's going to get any smaller. Just remember, make sure you keep that 1 as a negative, because here, this is a negative slope. It's heading down. I know this is a negative slope. I've got to make sure that I am putting down a negative slope then. Positive, negative over positive is still negative. And we can double check on decimals, but that should not be getting any smaller, right? So let's see, -1 over +3, not 6. Yep, there's that -0.3333, and as a fraction, -1 over 3, just like the last one. So there is my slope, and I want to say m is the same thing as slope. M equals -1 over 3. It's asking me for a rate of change. Rate of change is slope of y with respect to x. So how is y changing as x changes? And that's what this whole thing is, right? Change in y with respect to change in x. Okay, let's look at the next one real quick. The graph of linear functions is shown. What is the rate of change of y with respect to x? So we're still looking for a rate of change, slope. Now we're going to practice putting my 2 points, 2 perfect points. Let's see. I see this one right here would work, I think. I could also use this one. I think I am going to be using, let me see, I think any of these might work. No. One of them is slightly off. Oh, no, yeah. This one works. Okay. So here's some nice perfect points. They're on both the X and the Y. And let's see. Let's look at this one right here. This one's going to be, we're going to be using, this is my first point, and this is my second point. But you could also be using either one of these. Just make sure you have two of them. Okay. So on the first one, step 1, we did it. Step 2 was checking the rise or fall. So this time I am going up. I'm going up 1, 2. So plus 2 and over 1. So my rise or fall over run. Now I have plus 2. We went up 2 and then over 1. And if I double check on decimals or just think to myself, what is 2 over 1? Well, 2 over 1 is the same thing as 2. But we can also double check it. Always double check these fractions just in case. 2 over 1, 2. Perfect. Let's go look at the other page and see. Same question. What is the rate of change of y with respect to x? Well, rate of change means slope. Slope means slope equals rise over run. Rise over run. And pretty immediately, I should be able to tell if I need to fall here. Do I need to fall here? I don't. I see this going, starting here somewhere at a point on the left. So let's pick a perfect point while we're at it. Might as well. Starting here, and then it's going up to a second perfect point. So pretty immediately, I should be able to tell that this is positive slope. So in this case, I am just going to go up and then to the side. So let's see how much we go up by. I'm picking this perfect point right here. This is my first point, and I am going to go up 1, 2, 3. And to the side, let's see, 1, 2, 3, 4. So up 3. To the side, 4. 3 over 4, does that get any smaller? If I don't know, I'm simply going to put those in decimals. 3 over 4. 0.75, convert that to a fraction, and that is 3 over 4 still. Okay, cool. So my slope, my rate of change is equal to 3 over 4. Okay. Now hold on here a second. What kind of slope is this? Should be negative slope. Negative. I can see this is heading downwards. So I am going to be checking for some sort of fall over run on this one. If I get a perfect point, now be careful with your perfect points, because this one right here, you see how that's slightly off these corners? So that is not a perfect point right there. I've got to make sure it's right there on the corners, like this one or like this one right here. So I've got my 2 points, and now I'm just going to check for fall over run. See, 1, 2, negative 2, because I'm falling, and then 1, 2, 3, 4, 5, plus 5. So here I've got my fall over run, negative 2 over positive 5. Positive 5. Perfect. And if I double check that on decimals, that should be giving me negative 2 over 5. Can't make that any smaller. Yep, negative 2 over 5. And by the way, right here, you see how I'm just immediately typing negative 2? Make sure you don't put negative 2 over 5 and then use the negative there, because that's going to look wonky. I could also put the negative up here, just like in our problem, and I could put a positive down here, but it's still giving me the same result. So that's why immediately I just go -2 over and 5. You don't need to put +5 if it's already positive. Okay. So -2 over 5 was just -2 over 5. We're done there. Let's check out some of these big word problem ones. All right, real life ones. So here it says the graph shows the linear relationship. If I'm getting the word linear, I'm immediately thinking slope or y equals mx plus b. That's my linear function. Okay, so I'm thinking about that, and I've got the cost to rent a bike and the time in hours used. Determine the rate of change of the cost with respect to time. Here my time is using x. So I'm determining the rate of change of cost, which is y. Cost is y, so it's still the same thing. Y with respect to x, and we know that rate of change, it's slope. So if I'm seeing rate of change, that's just asking me for a slope. That's asking me to pick 2 points, rise over run. So let's do that. Pick 2 perfect points. This here, and we could use this one. And I'm just gonna go up 1. But hold on a second, because now is when I've got to look at my units. If I go up 1 block, is that really going up $1? It's not, because my blocks are now, what's the difference between 10 and 15? 5. So really this is covering $5. And then when I move to the side, 1, 2, okay, these are by ones, so that's okay, over 2. So here that 5 coming from our change in the units, these are going up by 5, 0, 5, 10, 15, 20. So up 5, even though I just went up 1 block. And then these ones right here, they're going by 1, 2, 3, 4, 5, 6, 7, 8. So those are just ones. 5 over 2, I can double check it on decimals, but that's just going to be 5 over 2. Or m equals 5 over 2. I'm just going to rewrite it. M equals 5 over 2. Okay, and the very last one. What is the meaning of my answer with the context of the problem? So using this graph, what was the 5? It was $5. And the 2 was really coming from the time or the hours. So every 2 hours, I am spending $5 on the bike rental, right? Every 2 hours, I'm spending $5. So then every hour, if I'm just moving 1, that's just going to be whatever 5 over 2 is, $2.50. Okay? So the slope really is giving me, right here, slope is the cost of renting a bike for an hour. And here I'm saying this is going to be, if I show this as 5 over 2, if I do decimals with these, because we like using decimals with money. 5 over 2, 2.5. Yes. So the slope is the cost of renting a bike for an hour, which really is $2.50 per hour. Per hour. So it's going to cost me $2.50 per hour to rent this bike. Okay. Let's see then the next one, just in case that one was a little confusing. All right, this graph shows the relationship between the number of dollars a worker earns and the number of hours worked. Okay, So for every hour, I'm earning some sort of money, right? If I have a job, I'm earning a certain amount of money per hour. Now, what is the rate of change, and the amount of money with respect to the number of hours? So same thing. Rate of change, I'm thinking slope, thinking linear. What is my slope here? So let's pick 2 perfect points. I could start at the 0 there. I could also do this one. Yeah, this one looks really nice. This one's picked out for me, so I'm going to be using these 2 actually, just because that last one's picked out. All right, so here I am at 160. And if I go all the way up there, I'm going 1, 2, 3, 4. But really, I'm going all the way up to 320. So how much did I go up? I got to find a difference right there. Just because this is going by 40s, it looks like, from 0 to 40. So here I went 40, 80, 120, 160. If I picked this point and this one right here, I could have also seen that, right? From 0 to 160. So either one of those. But let's stick with that point that I picked right there, just because that makes it a little trickier. Just in case you don't get that on your STAR test. All right. So that's 160 in between this, all the way up there. We went up 160. And now for our run, we are starting here, which is really 20. And then we're saying 20 all the way down to 40. So from 20 to 40, that's going to take us 20, right? If I'm going, these are going by 4s. Unit is 4 for my x's, and the unit is 40 for the y's. They're increasing by 40s. So here, if once again, just I can reasonably see that 20 to 40 is going to take me 20 more hours. Or I can start right here and say 4, 8, 12, 16, 20. So I moved over 20. What's 160 over 20? Let's look it up. 160 over 20 is 8. Desmos is a calculator. It does the heavy lifting for you in terms of that. Please use it as your calculator for anything like this. So my rate of change, or my slope, is 8. Now, what does this tell me about the actual real life stuff then? Well, it's just the movement between my x's and my y's. So here I'm going to say that every hour that I work, because that's what the x is, every hour worked, you earn how much? Well, we earn $8. Or you're getting paid $8 an hour. $8 per hour, right? So just checking the relationship between my hours and how much I'm making. Okay. Now, the very last part is just a little bit of vocab for these things. So slope or rate of change, we've covered that already. It's the difference between one point to the next point on the right. And then the x-intercept is what I call when I cross the x-axis. So let's just fill that in real quick. That slope that we talked about, the slope of a line measures the steepness of the line and whether the line is increasing. We call that positive slope. Positive. Or whether it's decreasing, which is my negative slope. And then the point at which the line intersects the y-axis. So my y-axis right here, the point crossing that is going to be my y-intercept. And anytime I'm on my y-intercept, so all these purple dots that I'm making right here, all of these, the x is at 0. So when I'm writing down my y-intercept, I better have 0, comma, something. Here it's 0, comma 3 because I'm at 0 for x, and then 1, 2, 3 for y. Okay, so that's called my y-intercept. Now the 0 then is what I like to call the x-intercept. So x-intercept or 0. X-intercept or 0, that's what happens when you cross the x-axis. So the x-intercept, we usually do it as a point. So this is x, comma 0 for y. Anytime I'm on this x-axis, my y equals 0. Right? My height here was 1, but my height here is 0. Okay, and then my x is 1, 2. So 2, comma 0. And we really call this a 0 as well because if we have some sort of equation, a point there is going to make your output or your y 0. But we'll talk about that later with different functions. All right, for right now, we just want to know a couple of these words, see if we can find them on the graph. First of all, slope. Slope, we defined it already. How we find slope? Rise over run. Rise or fall over run. Right here, this is some sort of positive. What's the next one? Negative. And the very last one is positive. So just real quick for little check. Positive, negative, positive. Okay. Now my rise over run on the first one, I want to pick 3 nice points. I'm just going to go with this 4 right here. And is that a good point? Let me see. Actually, I don't know if that's slightly off. I gotta be careful with them. I think what is a good point is for sure this 3, this negative 3 right here, and then this one right here. Let's see, up 2 to the right 3, up 2 to the right 3. This is a tricky graph. I don't like this one. Because they're slightly off. I think this one's a good one. And then I'm going to also pick, I think this one. I think those are for sure good ones. This one, you see how it's got that corner right here, slightly off. I'm worried about that one. But I think those two will work for now. All right, so check on the scale. Scale is going by ones. 1, 2, 3. 1, 2, 3. Okay. So this is okay. We can just count blocks. Let's see. My rise. 1, 2, 3, 4, 5. Now I'm to the level that this one was. So we went up 5. And then for my run, I'm going to start here. 1, 2, 3, 4, 5, 6, 7. So this is a weird one. That's why it looks tricky. I've got up 5, to the right 7. So my slope right here, this doesn't get any smaller. We can always double check on decimals, but 5 over 7 can't get simplified. Rate of change, same thing as slope. We already found our slope. Our slope was 5 over 7. Now my x-intercept is when I'm crossing this x-axis, which happens to be this little green line right here that I'm drawing. And there it is. I cross it at x4. And what is my y there? X is 4. My y is going to be just 0. If I'm on that line, y is equal to 0. Now my y-intercept is going to be wherever I'm crossing the y-axis. I cross it right there. Where the y this time, y is equal to -3. Oh no, sorry. Yeah, y is equal to -3. Here's the y part. And then what is my x right here? That's 0. Anytime I'm on the y line, the y-axis, x is equal to 0 this time. So my y-intercept, always 0, comma, the height. So let's see, -3. And 0, we've already said 0 is wherever that crosses. And we usually put x equals something. So x equals 4 for this case. All right, let's knock out a couple more of these. We already said we have a negative slope for the next one. M equals rise over run. Rise over run. This time's fall. And that is going to be equal to, let's see if we got some better points. I like this one. And let's say this one. So I'm going to be falling 1, 2, minus 2, over 1, 2, 3, 4, plus 4. So then here it's going to be -2 over 4. Let's see if -2 over 4 gets us something better. -2 over 4. Just -0.5 or -1/2. Okay. -1/2. So my m is equal to -1/2. Rate of change, same thing as slope. M is equal to -1/2. X-intercept, see where it crosses that x-axis. Right here. So my x is 2. X is 2. Y is always 0 for the x-intercept. Now my y-intercept. What color did I pick for the other one? Red. My y-intercept is right here. Where my y is equal to 1 this time. And for that part, it switches, right? X is always 0. And this one was 1. Okay. 0 means x equals wherever it crosses. So 2. All right. And the very last one here. We're trying to find slope. Here are my 2 perfect points. 1. This one looks slightly off. So I'm going to do 1 and this 5 right here. That looks good. All right. Positive slope, we're going up. Just double checking by 1s. 1, 2, 3. Yep. 1, 2, 3, 4, 5. So this time's going to go up 5 and to the right. 1, 2, 3. 5 over 3. Rate of change, same thing as slope. So that's 5 over 3. My x-intercept, where I'm crossing that x-axis, is at -3. So here I'm going to say -3, comma, find the y, bloop, 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 0. -3, comma, 0. That looks like a 30. 0. And my y-intercept right here crossing the y-axis at 0, because if I connect it to the x, this is also 0. 0, 5, 0, 5. And my actual 0 right here, that's going to be x is equal to -3. Okay, perfect. We're all done with these guys. Very last part is a couple of these word problems. We just got 3 of them. We're really doing the kind of the exact same thing and just interpreting a little bit more what it really means in real life. So let's see this first one. We got showing the linear relationship. If I'm thinking linear, I'm thinking slope. Between the amount of battery power remaining on the tablet and the number of hours it has been used. Okay? And what is the rate of change of the battery power remaining on the tablet with respect to the number of hours it has been used? Rate of change, my vocab word. Slope or M. And interpret. So what does it mean? Interpret means, what does this mean? All right, well, I know rate of change is M or slope. Right here, I've got negative slope. So I am going to be picking my 2 points as usual. Let's see, this one right here is at 1. This looks like a really nice point. I could use that. And the next one I could use right here. Looks good. So when I am going down this time, 1, 2, I really went from 1 to 0.8. So 1 to 0.8, if I want to double check that on decimals, let's say I'm going 1 minus 0.8. So the difference there between those two is 0.2. So here I went down 0.2, right? I went down 0.1, 0.1, 0.2. Okay. Don't let decimals intimidate you. If you want to think of this as 100, and this is 90, and this is 80, you went down basically 20. Okay. Aside from that, now when we're hopping over, I know we've got these two squares, but how much did I really hop over? I really hopped over from 0 to 1. So when I hop over here, I'm hopping over 1 hour. All right, so let's see. We had our power started at 1, started at 100% power, and now we are at 80% power. So we went down by 0.2 on the total power, or like 20%. And this happened in 1 hour. So really my slope here is whatever the negative 0.2 over 1 is. That's so weird. I don't like doing decimals and fractions and all that. So let's just put it in here. Negative 0.2 over, was it 1? Oh, hey, it's just still negative 0.2. All right, negative 0.2 is my slope. Equals negative 0.2. Now, what is the 0? 0 we said was x-intercept. So let's see where our graph is crossing x-axis. Looks like it's crossing it right here. So my 0, x equals 5. And what does it represent? So let me ask you a question. If I start with 1 as my battery, and then I go down all the way to 5 hours, where's my battery at now? What happened? I started with full battery. I can connect it over here, and I can see my battery's at 0. So this is just 5 hours is how long your battery's gonna hold. So after 5 hours, you Or what? You have 0% battery left. Right, that's just when I reach 0. So that's why it's called a 0, because that's when my Y, this side, that's when my battery reaches 0. All right, now what is the y-intercept and what does it represent? Okay, so my y-intercept is 1. So I can say y-intercept 0, 1, because that's the y. Okay, and anytime I'm at 1, what does that mean for my battery? Because that's really what the y is. What does that mean for battery? Okay, it means that I have 100% battery or power, or 1 full battery. Okay, that one's a little tricky just because of the decimals, because of the 1 to a 0 for the battery power, but we got through it. These two should be a little bit easier. Okay. The graph shows the water level in tank drained at a constant rate. Constant rate, that means it's going without changing. If I see constant rate, I'm also thinking slope, by the way. Okay, so what is the rate of change of the height of water with respect to time? I'm seeing rate of change. We know this is m. Interpret. So my m here, and look, they picked out 2 points for me. I don't have to do that much work then. We're going from 10. Let's check our units. Our units are going up by 2 every time. So when I'm going down, I'm going to go down by 2. From 10 to 8, this is minus 2. Minus 4. Minus 6. Yeah, 10 minus 6, you get to 4. Okay. And then when I'm going over, I'm going to say, this is 0, 1, 2, 3. Okay, yeah. 1, 2, 3. That one I can just use 3s. So this is negative 6 over 3. Simplify that real quick. That gives me negative 6 over 3. Negative 2. My rate of change is negative 2. So my height of the water is changing by negative 2 every hour, right? I've got a tank. It looks like it's draining. Yeah, it's draining. If it's draining, it's going to be lower and lower and lower, the water level. So here, my height in inches. This tells me inches. My water is draining or decreasing at 2 inches per hour. Height is my water is draining or decreasing at 2 inches per hour. You could also say my water height, the height of the water. Okay. What is the x-intercept? Next one. What is the x-intercept of the function? What does it represent? My x-intercept right here at 12. Oh, my bad. I'm just tired now. My x-intercept right here at 6. Here's the x. So this is x, 6. Y is always 0 there. And when I get to 6 hours, right? What's happening with the water height? It's all down to 0. So this tells me after 6 hours, my water height is at 0 or the tank has been drained. Zero. Tank has been drained. Okay. Very last one. Here we go. Now it's the y-intercept, the one that I did before. Y-intercept right here at the y-axis at 12. 0, comma, 12. What does this represent? Well, this really represents the maximum of my height in this case, or because it's at the y-intercept really gives me the initial. So the tank initially, how do you spell it? Initially had 12, or a height, water height, of 12 inches. Okay. Very last one. We're almost done. The graph above shows the relationship between the number of miles the truck is from its destination and the number of hours the truck has been driven. So as I'm driving from its destination, and then I finally get to my destination, right? Okay. Let's look at rate of change first. It also has some points here. Don't get tricked though. Look at that. That's right in the middle. That's not a nice perfect dot. We want to pick some perfect points. Okay, so let's see if we do have one. Okay, here we have that. We have this one. Also, this right here would work. This one's in between them. I don't want that one. Or this one right here. Okay, I am going to pick these two middle ones. Here's my first dot. I'm just going to start there. Now, if I check my units, and maybe write a reminder to yourself, check your units. What this graph is increasing by. So right here on X is going by ones. 1, 2, 3, 4, 5. That's okay. So the unit here is 1. But when I'm going on Y, from 0, I don't go to 1. I go to 20. So this is increasing by my unit on Y is 20. All right, so now when I'm counting my blocks, every block for Y is 20. So here I'm going down 20, 40, 60. So this really is minus 60, right? And I can double check. What is 180 minus 60? 120. Okay, cool. So we've got minus 60 over 1, 2. These ones are going by ones. So 0 to 2, 2. And if I make that a little bit smaller, negative 60 over 2, you can probably do this in your head. If not, plop it in decimals, negative 30 equals negative 30. So my slope is negative 30. What does this negative 30 really tell me? Well, I know this is a change of the height with respect to time, or the hours. So my height, oh, this is copied wrong. Look at that. Height of the water. This is not height of the water. This is distance. My distance to destination is decreasing because I've got negative. From negative, I'm decreasing by 30 miles per hour. So every hour that I'm driving, I'm getting 30 miles closer and closer and closer to my destination. Miles from its destination. I'm getting closer to my destination. Okay. The 0 of the function, let's look at X this time instead of Y. If I'm looking here at X, my X is 6, 0. Once I've finally driven 6 hours, how much do I have left to drive? 0. So after 6 hours, I reach my destination. I don't have any more distance to drive. Okay. Very last thing, y-intercept. Y-intercept here. Let me pick a different color. Y-intercept here. Right there. There's my y-intercept. Okay, that's at 180 for the y. That must be 0 over here. This is a y-intercept. Okay. And what is the y-intercept? Similar to the water level and really similar to the battery. It's initial battery, initial tank height, right? Water height. So this is going to be initial miles from destination. So let's say this is Waco and I'm driving to Dallas. Got 180 miles to go. But after 6 hours, really Waco's 2 hours away. But after 6 hours, I'm going to reach Dallas. Okay, so my initial here, always my initial. If I'm crossing the y-axis in real life, it just usually means this is where I initially started. Okay? All right. So hopefully that was a little helpful. I know those are a little bit long notes, but now you have the video. You can always go look back and see if you have any questions or anything.